Hello everyone. So let us start with aggregates in the NoSQL. In the previous session, we introduced the NoSQL concept. As a part of that, we have discussed about the basics, what is NoSQL and all. So one of the concept of the NoSQL, it is possible. The NoSQL is possible with the aggregates aggregate storage process. So now let us concentrate on this. In the regular traditional databases, in the RDBMS, the data will be stored as the tables, and inside that there are the rows and columns, as you know. So the rows will be stored as the tuples, okay, and the columns will be represented with different data types and other properties. Okay, and each piece of the data which is stored as the tuple rows and NoSQL databases. Actually, the NoSQL databases they will not store like the tuples. They are introducing the different kind of storage, meaning that the it is called the aggregate oriented, meaning that which is required and with all the related data will be stored closely. That will be there in the regular aggregate databases. So aggregates, they are useful in the key value storages and document databases and column family stores. All these are the various kinds of aggregate databases, right? Now, differences between the relational and aggregate oriented models, we have to see about that. Aggregate, they will store the related data together as a single entry. So all the related information that will be stored as a single entry. But in the relational databases, there will be fixed structures of different tables. So instead of normalizing the RDBMS, we have the normalization concept, meaning that by using some rules, we have to separate the tables to maintain the consistency and those are some acid rules. Those to use all those things. We have to separate that. That is called the normalization and the aggregation that can store the nested objects. That instead of that, we can store the nested objects and and it will avoid the need for complex joins. You need not go for the complex joins. Actually, if you are normalizing the data will be stored in different locations and different tables. So you have to write a query with the joining joins. So the joining concept, it will be the complicated and it will very difficult for execution. So all these will be reduced because of the aggregate databases, because all the related data will be stored at one single entry. Okay, so it works efficiently in the NoSQL databases like document stores like MongoDB, CouchDB. So all these are the various things and the key value stores and then column family stores. They are the Cassandra and HBase. So these are the various kinds of data storages by using the aggregate method. Okay, and then there is a small example here, customer aggregate. There is the customer aggregate database. In that you can observe that customer ID and name and then billing address, orders. Inside the order, there will be the number of orders. They will be given in the separate entries within the braces. So you can observe that order ID, order items, shipping address, order payment. Again, the order payment, it will be different. They are having different elements, so CC info, transaction ID, billing address, all these are having the order payments. So like this, all the related information of a say one customer there that is available in one unit. Okay, so there is no fixed structure and it may be changed. So you can observe that here in this, if you want to maintain the same content in the relational databases, you have to maintain a separate list, a separate table for order items, and separate table for the these orders. We have to maintain a separate table for the orders, separate table for the order payments, and separate table for the customer information. So we have to write the complex join to get the related information of the customer. So it is very complex architecture. So this is very easy to identify. Everything is available at that place so that it is easy. Now we can represent the aggregate databases like this. The customer will be there, the name will be there, the name and billing address is there. The billing address, it will be the address and it will be the order payment. Again, the order is having the order payment and order item. That can be again go with the product items, and these are the various things which are represented in the regular databases. All this information can be combined into a single unit as we have seen in the previous slide. So we can mix all those things, all the related information at one place. So this is the speciality of the aggregate databases. So, and now what is the aggregate? The aggregate, it is the collection of related data that is treated as a single unit. We will store the related data as a single unit. And it introduced in the domain-driven design (DDD), and it aggregates that define the local boundary for the data access and consistency. All these are maintained, and aggregates. It helps the maintaining the consistency and improving the query performance and simplifying the data replication and sharing. So how it is maintaining the consistency? Since we are storing the all the related information at one place only, so that we need not modify number of times if something is changed. Okay, so it will maintain the consistency, and most of the databases, they doesn't allow for the updates. Generally, we can add, but it doesn't allow the updates in the distributed environments and big data. So, and improving the query performance, obviously, because it will be executed on top of parallel execution and the distributed environment. And it's simplifying the data replication and sharing also. So the data replication, since all this information is available, all the customer information is available as the bulk, so that can be replicated into different places, so that the replication is also very easy. Otherwise, it has to replicate with different tables and all this. That is a different case. Okay. And there is a small example. And in the e-commerce system, the order can be aggregated with order items, shipping address, payment details. And instead of storing all these in the separate tables, all of them can be embedded in a single aggregate environment. That may be the JSON format, or that may be the other formats also. So that is the aggregate databases. Now, benefits of the aggregate-oriented databases: it simplifies the data access because everything is available at one place. No complex relations that is required, and it improves the performance in the distributed systems on top of the parallel execution on top of the distributed environment. It is going to execute, and better consistency models, they're available because as we have seen, if you want to change, you can change the entire record completely. That's it. Okay. And easier replication and scaling. The replication is also very easy because of the availability and all this. And types of aggregate oriented databases. There are various aggregate oriented databases available. They are the key value stores. There is a Redis and DynamoDB and document stores MongoDB and CouchDB and column family stores. They are the Cassandra and the HBase. All these are the various things. Okay. And the in the aggregate boundaries, what are the aggregate boundaries and data models, how they are? That is a scenario, and the scenario and preferred aggregate structure, which type of aggregate structure is required. That is, let us say, for example, if you want to fetch the order with all the items, payment and the shipping address, if you want to get everything in the single shot, then it is better to store a single aggregate. Otherwise, if you want to get if you want to analyze the sales trends and across the way multiple orders on the different orders, then we have to maintain the store orders separately, and we can use that by using the index for the analysis. We can refer that. And let us say another scenario is if you want to update the inventory levels across the multiple orders, if you want to update that, then store inventory should be separated because because we have large amount of data at the same place. Instead of that, better to separate this the inventory separately so that it is easy to manage. So these are the various components and various things which are required for the aggregate databases. Now, in the next session, we will discuss about document databases and other components. Thank you.